Dear students, the next scientist who gives an idea about an atom was Niels Bohr, and he gives an idea that the protons are concentrated on the center of the atom and electrons are revolving around the nucleus. Also, he predicted that there's a charged particle or a particle which has no charge having mass is concentrated on the center, and he predicted the idea about the neutron. And one more thing is that he gives many clear ideas about the atom, and he gives that electrons are revolving around the nucleus. That path is called an orbit. The orbit number 1, 2, 3 or KLMN are given by this scientist Niels Bohr. And the atomic weight, the weight of the atom, is the sum of weight of neutron and proton, which is concentrated in the center nucleus. See, an atom is represented by writing a letter that sodium. The atomic weight is written in the left side above that, and the below it is the atomic number or the number of proton or electron. In an atom, the proton, positive charge and negative charge are equal, so it is called an atom is electrically neutral. And we can also calculate the number of electron in an atom or in an orbit by the formula 2n square, where n is the shell number or orbit number. For example, for the first orbit, 2n square, that is 2 into 1 square, that is equal to 2. In the next orbit, second, that is 2 into 2 square, 2 into 4, that is equal to 8. Like that, the number of electron, maximum number of electron that can be accommodated, can be calculated by this way. Okay, you see this video and you will be more clear about the picturization of an atom. Okay, thank you.
Bohr's model of atom. Various models of the atom have been proposed by eminent scientists over the years. These models have increased our understanding of the atomic structure. Among these models, Rutherford suggested that electrons revolve around the nucleus in well-defined orbits, but there was a problem with this. The motion of electrons in Rutherford's model was unstable because any charged particle moving in a circular path emits electromagnetic radiation. Thus, the electrons would lose energy and fall into the nucleus, making the atom highly unstable. Then, which would be a better model of an atom? To overcome the objections against Rutherford's model of atom, Niels Bohr in 1913 proposed a new atom model. What does this model propose? It first proposes that electrons revolve around the nucleus in specific orbits, and these orbits are associated with definite energies and are called shells or energy levels. These orbits or shells are represented by the letters K, L, M, N. The maximum number of electrons that can be accommodated in a particular orbit is 2n to the power of 2, where n is the number of the orbit. Thus, K shell would have 2 electrons, L shell would have 8 electrons, M shell would have 18 electrons, and N shell would have 32 electrons, and so on. That said, what does this model next propose? It next proposes that the maximum number of electrons that can be accommodated in the outermost level is 8. And finally, it says that the orbit closest to the nucleus has minimum energy and the orbit farthest has the maximum energy. Well then, does an electron radiate energy by itself? Since electrons move in a particular orbit, they do not radiate energy by themselves. What happens instead is when an atom absorbs energy, the electrons get excited and jump into the next higher energy level. The electron can radiate energy and return to its original state or drop down to the next energy level. Bohr's model works well for simple atoms and is easy to understand. It is one among the atomic structures still in use today, and the other being the quantum mechanical model. Atoms are the general term used to describe pieces of matter, that is, matter is composed of atoms. That brings us to the question, what is an atom? An atom is a basic unit of matter that consists of a dense central nucleus surrounded by a cloud of negatively charged electrons. Studies of atoms dates back to as far as the 5th century BC. Democritus, a Greek philosopher, described atom as that which cannot be cut up further. Acharya Kannada of India defined atom as eternal and indestructible and which cannot exist in free state. John Dalton proposed that atom was indivisible and indestructible, but this can only be said so if it is not composed of further particles. Are there particles that are smaller than an atom? Sure, there are. The discovery of the fundamental particles, protons, neutrons, and electrons inside the atom led to the failure of Dalton's atomic theory. This also proved void Democritus's and Kannada's theories that atom is indestructible. Who were the people behind the discoveries of these particles? They were none other than James Chadwick, who discovered neutron, Eugen Goldstein, who discovered proton, and J.J. Thompson, who discovered the electron. So how do we explain the arrangement of protons and electrons inside an atom? To explain the arrangement of protons and electrons inside the atom, J.J. Thompson prepared a model for the structure of the atom, known as Thompson's model of atom. The model of an atom proposed by Thompson is similar to a Christmas pudding. In this model, electrons are arranged in a sphere of positive charge like plum in the spherical Christmas pudding. So it is called plum pudding model of an atom. Do you know of any fruit that we can compare Thompson's atom model to? Well, it can be compared to a watermelon. The negative charged electrons are like seeds embedded all over the positively charged sphere that is compared to the edible part in the watermelon. Thus, Thompson proposed that an atom consists of positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so atom as a whole is electrically neutral.